Hello everyone. After some time being away and being busy because a lot of things have been going on in my private life, I'm finally back here with another video. In this video I want to do a short walkthrough of a machine on tryhackme, which I found pretty cool. And this machine is called Brainpan 1. Our goal here is to hack this machine, eventually gain root access to it. So in this video, I am going to walk you through this process. We will be seeing some scanning and enumeration. Also, we will have some reverse engineering in there, a buffer overflow through which we're gonna gain the initial access to the machine. And then finally, we're gonna escalate our privileges to root. So let's get started. To get an overview of this machine, let's first do an nmap scan. I'm doing a TCP SYN scan here with T4. That's going to be the speed, and I am going to use -p- to scan all ports. So let's fire this up and see what comes out. The nmap scan has finished, and we can see here that there is a port 9999 open and the port 10,000. So in the next step, let's poke around a little bit. I'm going to just take the IP here and I am going to do a netcat connection to it. And here we get a nice prompt and it says, "Welcome to Brainpan, enter the password." So let's just enter something. Okay, access is denied. This doesn't seem to get us anywhere. So what you can do is you can take this port 10,000, for instance, if you don't know what it is, and just throw it into your browser, as I did here. And you can see that there is a graphic here, and we have some sort of a web server that is hosting this. So in the next step, I am going to do a scan here and see what's behind this. Now let's do a little directory scan with GoBuster. GoBuster, as far as I know, isn't included with Kali Linux that I'm using here. But it's a very nice application, works very well, and I can highly recommend this for anyone who's into like sort of this pen testing stuff or these capture the flags. So I'm going to run it on the HTTP on this website, and here I'm just going to use a word list that's included with Kali. This directory list 2.3 medium. I like to use this one. I always get good results with it. So let's fire this up and see where it takes us. Okay, so already a result has come in, which looks highly interesting, and it's this bin directory. So let's just throw this in here. Wow, cool. We found the Brainpan executable. That's pretty nice. So we're just gonna copy this. And then we're gonna just with wget download this real quick. Here I loaded the Brainpan executable into Ghidra, did an analysis, and when you look at the functions over here, it's pretty easy to work your way through and find the main function. The main is right here. I am going to focus more on the decompilation result as it's pretty good. The first thing that you see here is the nice prompt that we got that said, "Welcome to Brainpan, enter the password." Now there's some WinSock stuff going on. Eventually you get this creation of a socket, this binding, then listening, and the interesting part is what happens when a new connection is accepted. That is going to be down here in this function getReply. If we jump in here, we can see some pretty interesting stuff. So first of all, we have the password here. Now what is passed in is going to be the message that you sent to the executable, and then it's going to be copied to this local buffer. In the end, this local buffer is just going to be compared to shitstorm. So that means this is the password. So let's try it out. So back on Kali, let's enter this, and we have an access granted. So we found out the password, but it doesn't give us access. Now we're going to go back to reverse engineering and code ourselves a buffer overflow to gain access to the machine. Let's begin by talking about what we want to achieve. Here is the stack layout, and in here there is the part that holds the local variables. That is where the current stack pointer points to, which is followed by EBP and eventually the return address. So the EIP, the instruction pointers. After that, follow the parameters that were passed to the function, and you have your stack frame. So the goal that we have is we want to overwrite the local variables with just some random garbage, for instance, just a bunch of A's. Then we want to overwrite the EBP as well, maybe with some B's. The next thing that we want to do is we want to overwrite the return pointer, and we want to override it with a jump instruction that is going to jump to some code that we're going to inject. So we want to jump to shellcode. So here we have a jump to shellcode. And what you usually do is you add some knobs here, so no operations. This is just so the jumping becomes easier. And this part here is called a knob slide. The code or the execution will go the following way. A jump is going to be done. We're going to land inside of this knob sled. Then we have no operation after no operation. And eventually, back here, we have our shellcode. And this shellcode is going to connect back to us from the target machine, giving us a shell and thus access to the system. So let's program this. Now back to the function that we want to write an exploit for. You can see here this buffer has 520 bytes, and this variable here has 4 bytes because we are working with a 32-bit program. Of course, there is the EBP that we also want to overwrite, which is going to be another 4 bytes. And after that, we have the return address, which we want to manipulate and replace with an address where we want to have our jump. Now, when I did this challenge, normally you could run this program with a debugger and just get the offset right. There are a couple of tools. One that's popular is, for instance, Immunity Debugger with a plugin called Mona. That is pretty widespread, I'd say. Of course, you can also do something like this with X64 Debug. But for this challenge, I didn't do that. I actually went ahead and I said, this is enough information for me. So I started with 520 bytes, sorry. And then I gradually added 4 bytes. So that's how I did it. All right, I'm back here on Kali. I started a Python script, and the first thing that we want to do is generate a payload. And I did this with MSF Venom. I chose the Linux x86 shell reverse TCP because the challenge description tells us that we are dealing with a Windows executable which is running on a Linux system. So it's probably going to be running under Wine. Before I tried it this way, I must say I didn't read the challenge description thoroughly, and I went for a Windows reverse shell, and the results weren't what I expected. So I did it right the second time. And with that being said, let's generate a payload. Now, the only important thing that you have to remember is for this lhost, you enter your machine IP. And also in a real pentest, you may want to change this 4444 to a different port, because this port is the standard Metasploit port for reverse shells and just for attacking. So that's maybe something that's worth to note here. Here's the generated payload. Everything is in C style. So to have this in a Python script, you can just go ahead and use these parentheses, and then Python will be able to interpret this correctly. Next, we said that we have an offset, of course. In this case, I am going to set the offset to 524. Next, we need the part that we want to overflow, so the local variables. We're gonna overflow these with A's, an offset number of A's. So it's going to be A times offset. Then we will need some sort of a return address, which we don't know yet, followed by some padding. And here we are going to go for NOPs, of course, and this is in hexadecimal 90 for the architecture that we're targeting, and we're just going to say it's going to be 32 NOPs here. Now let's find out what this return address is going to be. Back in Gira, let's look for a jump ESP. Now this doesn't always work because these addresses here, they will often not match up with what you have on the target. But I was pretty lazy and I just do these for fun, so I tried it that way, and I'm going to show you how you can do that. So you can go to search and search program text. You go ahead and click on listing display and on all fields, and then you search for the instruction that you want. In our case, we want to jump back to the stack, to the top of the stack, and that's going to be jump ESP. So if you say search all, you get an address for this instruction, and this is exactly what we're looking for. So back on the Kali machine, I threw in the return address, this jump ESP. Of course, we have to write it backwards because of little endian, the byte order, and I'm just gonna add a small comment here. And next, let's put together the buffer that we're gonna send over to the program. Now you do this in the following, or you can do this in the following way. This is a pretty cool trick that I saw over on John Hammond's YouTube channel. You go ahead and you throw all of these things that you have up here into a list. Then you just get a nice overview of all of the individual parts of the payload. And of course, you are going to have to put them together. You can accomplish that just by using Python's join here. So the next part is going to be a socket connection. So we're gonna import socket up here. And then you can just say s socket.socket and then af inet. And what we're gonna want is a TCP socket, so we're gonna go for sock stream. Okay, now down here, the thing that we want to do is we want to say try, and we're gonna use this member of the socket, which is connect, pass a tuple in here of the IP import we want to connect to. And in the case of this program, we first want to receive a buffer, because that is going to be the title that is sent over to us. We want to receive that, and then we will send our buffer with our payload, with our exploit over as an input. So here we can just print that out, so we know what we're receiving, that we're on the right track, just with a print and then call another member receive of the socket. Next, just gonna add another print here just to see where we're going, and then we're gonna send over the buffer. We want to do that as raw bytes, and we want to add a \r and \n, And then, of course, there is going to be some sort of encoding happening. So I'm going to choose Latin 1 here. And then let's take this here and just say send. And of course, if an exception occurs, we're just going to say couldn't connect. And that's it. That's the whole exploit. Just to reiterate, we're going to overflow the locals, change the return address to jump ESP. Then we're going to have some padding, which is our knob slide. And eventually we're going to hit the payload, which is going to connect back to us. Of course, I forgot, as per usual, the most important thing. And that's the IP of the host that we want to attack and the port. So the port was 9999. And I'm just going to throw the IP in here. We already have it down here, so that's going to be no problem. And then we can connect over. Let's just have a quick look at something else. And I said at first that with this command here, with this msf random command, you can generate yourself a nice reverse shell. Here, this shell is actually going to be staged. And I don't want to use MSF console. So there is also the possibility with this command to create an unstaged payload. I ran this and added the payload in here because I want to set up a netcat listener. So that's another change that I made here. Let's fire up netcat, listening on 4444, and then we're going to run the exploit. So, pretty interesting. On this side, connection was made to us, but we don't actually see anything. Once you enter something like HumI, you do get an output. The problem is just that you don't have a nice prompt. So let's close this window, and then with some Python magic, we can spawn a shell. And now we have our prompt. So from here, let's go ahead and do bin bash. So we get a bash shell, and we can see that we're someone named Puck. And we're in our home directory. From here on out, you can go ahead and enumerate the machine to escalate your privileges, and I'm gonna show you how to do that next. So after poking around in the system a little bit, one of the things you may come up with to just try out is to find out which commands can the user Puck run as sudo. So if you do sudo -l. Here, this is pretty cool. You can see right away without a password, you can do sudo home anansi, another user, bin, and then anansi util. Let's try that out. And here is this command run as root. And we have the following actions. We can do network, proc list, and manual. So with network, it says, okay, permission denied, of course. Sorry about that. You can list the network interfaces, the IP addresses. Then if you do proc list, you don't get an output because of your terminal type, but that's okay. The one command that we are actually interested in is manual. And manual is going to open up the manual page for some command like, let's say, ls for us. And the terminal is not fully functional. That's no problem. We just press return and then we're in here in the manual pages. And this is the point where we can escalate our privileges to root, because as we're running this as the super user, and there is something in the manual where you just press exclamation mark and then, for instance, bash, you can run a command. And as we are running the manual as root, we are running the command bash as root. And that's it. That concludes this little walkthrough of Brainpan 1 on tryhackme. I hope you learned something cool on the way. And with that being said, I'm going to end the video here. Thank you very much for watching. It would be nice to see you again on my channel. Goodbye.